Welcome back. Let's do some practicing for object-oriented programming. So first of all, let's implement some classes similar to the ones that were done in the lecture portion. Let's call this basic classes. Make this slightly bigger. Sticking with the capitalized convention. Let's create a few different methods for this. So we use the dunder init. And I won't bother to have any initialization arguments in this one. I'm just going to have two lists. So I'm going to create a list of courses, which I'm just going to initialize to empty initially. And we'll also have a list of grades. Really, I should call this marks, now that I think about it. It's going to be numeric. Okay. And I'm going to define a function called getGPA. And that's going to have no initialization arguments. So what we're going to do here is I'm just going to go through the list of marks, and I'm going to total them all up. So I'm going to say total equals 0 for mark in self.marks. Now you always need that self dot in Python. That's one of the reasons why every single function has a self argument. In some programming languages, you can just say marks. If there's no other marks around, it'll automatically know that you mean the instance variable marks. But that's not true in Python. You have to say self.marks. So for mark in self.marks, we're going to say total plus equals mark. And then finally, when we're done, we'll just return total divided by the length of self.marks. That'll give us our average. Now, it's not going to be a GPA in terms of a 4.0, but close enough. We're also going to need a function called setCourseGrade. Call it set course mark. I want to be consistent here. Otherwise, it's going to annoy me a little bit. So all I'm going to do is I'm going to say self.courses.append course. We learned about that before. So append adds a new element to the end of a list. Courses is currently empty, so this is going to add a new course to the end of the courses list. And same thing for marks. We're going to say marks.append mark. So now that's going to add the course to the list of courses and the mark to the list of marks. And now, if I wanted to, I now have a mark in my set course mark. In my set course mark, I'm setting a mark in my marks list. So now I can use the getGPA function. I'll get more than one. Actually, the way it is right now, if I call getGPA before I add a course grade, it's going to have it divide by 0 there because I'm dividing by the length, which initially is 0. Okay, so we could write some code to test this on its own, but let's just move on and also create the other class, course. Okay, so course is relatively simple as well. We're going to create a dunder init function. And let's create some initialization variables again to demonstrate both techniques. So this is sometimes called the constructor. All I'm going to do is say self.code equals code. That's again, take the code argument and put it into the instance variable. And self.name, take the name argument, put it into the name instance variable. Now I'm going to use information hiding here. So one of the things I could do is I could use an underscore prefix in front of code and name to indicate that these are private variables. So I could do that if I want. And so why not? Let's do it. And I'm going to create a getCode function, which is designed as an accessor. So let's actually label this as an accessor, also called a getter. And the purpose of this is just to return self.code. I'm going to do self._code. Again, that's just a reminder so that I know that it's always private. So if I'm outside of the course class and I'm typing code and I find myself typing something _, and some variable, it's a clue to me that I'm probably not using it the way I was supposed to. It's also supposed to be a self code, a set code function. So I'm going to pass self as the first argument and the new code. By the way, those variables don't have to match. For example, you could have a variable called new code. This is called a mutator function, also called a setter. And all I'm going to do here is I'm going to say self dot underscore code equals new code. All right, maybe just to save some time, let's just modify these code functions to be name functions. So let's actually just use a multiple cursor here. So we'll just do all right, so we've got a bunch of cursors. If you don't remember how I did that, it's just hold down the Alt button and you can click in a new spot. And now when I highlight, it highlights all of it, I can just replace it with name. Okay, so that was a lot easier than typing the whole thing again. Let's create a dunder_str function. Let's also create one for student. Wait, we don't even have a name for student, so that's kind of a problem. Let's create a name. So let's say self.name. And we'll just initialize the empty string. And we're going to have a getName function. I'm not using the underscore notation here, but you know, I probably should. Let's be consistent throughout the program. Let's change all of these to underscore. And so over here, we're going to have to change this to underscore, and this, and this, and this. All right, so I'm just going to create a get function and a set function. Okay, so now we've got a get and set function. So now when I create a student, I'll have a name at least. And so what I could do is I could have a dunder_str function. They, by default, only take self, and they always return a string. And of course, we could do type annotation to specifically be a string if we really wanted to. And self, by the way, the type of self would be student. So anyway, in this case, we would just return an f string. And as an example, the simplest thing I could do is just self.underName. I could calculate the GPA, I suppose. Let's even put GPA colon and then the GPA. Kind of weird because that's usually confidential information, but since we don't have any other data to display right now, it actually works pretty well. For the course, let's return an f string that has, let's say, the course code, and then in brackets, the name. So we'll do self.name, undername rather, and then we'll say self.undercode. All right, so let's actually give this a quick test. So what I'm going to do is create a new student. So student was special. I only created an init function that doesn't have an initialization arguments. So what I'm going to do is I'm going to create Liza, and I'm going to create a new instance of student. Then I'm going to say Liza.setName. Okay, so let's say Liza's name is Liza Brown, and then we'll say Liza.setCourseMark. We've got to create a course first. That's silly. So first things first, let's create Intro to CS. And I'm going to create a course. Now let's look at how we can initialize course. Now just keep in mind, by the way, you can create multiple dunder init functions with different numbers of arguments. I've only created this one, and it has 2 initialization arguments. The self we don't count. So I'm going to put a code and a name. So let's put the code for Intro to CS. Okay, maybe there's space here. So I'm going to set the course mark of Liza to Intro to CS, and let's say that she received 93.5. Let's actually do that first. So we could call, we don't need to call getName and set name and set code here. So that's actually perfectly fine. Let's just... All right. So that's relatively straightforward. You know what we should also do? We should print Liza. And instead of printing Intro to CS, what I think I'll do is I'll say something like str course equals str intro to CS, just to show you that the str function is not for printing. What it is for converting to a string. So this function here takes any object and converts it into a string. Well, objects that don't have a built-in way of doing that are expected to implement a $str function. So for things like integers and stuff, that's all built in. But in this case, this is my own class, and Python has no idea how I might want to convert this into a string. So that's what we're doing here. By hand, converting it to a string. So let's run these two print statements here and see what we've got. And division by 0, yeah, of course. That makes perfect sense. Oh wait, no, it doesn't. I must have made a mistake here. Get GPA, oh yes, right here. When I'm printing Liza, I'm doing that before I set her first grade, and I was looking out for this. So I just gotta make sure. The reason why it is because I'm computing the GPA in the str, the $str function. And by doing that, it means that it calculates the GPA before there are any grades. So let's just put Lazo's print down here. Let's just do that. All right, so running it again, there we go. Liza Brown, GPA. She only has one course, so that's fine. And then the course intro to CS. Alrighty, so nothing too complex about that. Let's now create a subclass. So we'll do inheritance. So class online course, it inherits from course. I'm going to create a $init function, and I'm going to initialize this with a code and a name. You know what? A code and a name and a web address, just to show you how the $init functions do not need to match each other. So course has a $init function that has self-code and name, and online course has self-code name and web address. Okay, so first thing I'm going to do in this $init function is I'm going to call the $init function of the parent class. So I just call super.init, and I pass it the ones that it needs. Why do I only pass 2 here? Well, remember that this is going to represent the current object. Okay, so this is like the self, and then code and name. So there are a total of 3, and that matches what we've got up here. Okay. And then what I'll do is I'll just set open to public, another specific variable here. I'm just going to set that to false by default. And I'm also, actually do that first, I think. I'm going to set web address. Oops. Equals web address. And in fact, I forgot to put an underscore here. All right. So let's create some getters and setters for these two properties, or these two instance variables. So I'm going to say get web address. I'll just return under web address, and we'll have a set web address. Why not? Okay, and why not? We should also have a is open to public. I'm just going to return self dot open to public. And we also have a set open to public. I gotta stop switching between keyboards. This is getting silly because they're very different layouts. I'm gonna get used to one layout. I turn into a bad typist on the others. Okay. And I guess we should have a dunder str. Why not? We had ones for those two. Let's be consistent. So I'm going to return f string. And for this one, I think what I'll do is I'll put the self.code, and then in brackets, self.undername. And then maybe we'll put the web address too. Okay. I guess just so it looks different. What a lot of people do for the str functions is at the beginning they'll put the class name. So they'll say something like student and then in brackets they'll put some additional values. So anyway, it's something to keep in mind. So for course, we could say course, and then the brackets around all the data. And for this one, we could do the same. Online course. Could do that. All right, let's create an online course. Let's call it Intro to Linux. And we'll just say online course. We'll give it a code. Let's call it a computer science course. And maybe it's called 1010. Let's put online in brackets so I know that it's an online course. And let's say Liza took this course. And she scored an 89. All right, anyway, so there we go. So suppose we should print Liza a little bit later. No, maybe converting the course to a string should also be done later. Oops. I actually meant to cut that, not copy it. Okay. And let's just print directly Intro to Linux. Okay. All right, let's see what that looks like. Just keep in mind, FYI, oops, I forgot, yes, I've got to put 3 arguments here. Just keep in mind, the str function is also used when you use the string in an f string. So for example, if I were to do something like this, this is also going to call the dunder str function to convert it to a string. All right, so this one's going to need a web address. Let's just invent one. www.learnlinux.org. Learn Linux in 8 seconds. There we go. Oh, it's not going to conflict with somebody else's address. I don't know where that's going to take you, so sorry. Don't visit this address if you're a little squeamish about websites. All right, there we go. So now we list all of them. You can see that it prints all 3 of the properties here. So in brackets, it has the full name and the web address for the online course specifically. Seems good. And now you can also see that Liza's mark reflects the 2 grades that we've entered for her. All right. So let's go for another example of inheritance. Let's do the animal class. So we'll create a dunder init. And it just has a name. And let's continue using the private variables here. Then we're going to just, I don't need to create get and set because I don't happen to use it for anything. But just keep in mind that generally speaking, you would have to do that. So I'm going to create a neat function, which is just going to print that self.names eats. And maybe just to make things efficient here, let's just copy and paste this so that we can replace it. So what I'm going to do is I'm going to set this to lion, and in brackets animal, so we're going to inherit from animal. And then what I'm going to do here is I'm not going to use this syntax. I am going to use our super syntax. I'm going to use super.dunderInit self.name. And that's because the super class also takes a name argument. Here you can see. And so I'm just making sure to match the signature exactly. And because that function is going to save it as an instance variable underscore name, I can just leave that to the parent class to do that. So I don't have to do anything inside the init function here. So I'm just going to go on to the roar function. So let's just modify this function here. And then we'll just change this to roars. All right. And we can create, well, now let's get a couple more classes. So we'll create a tiger class. Tiger class is going to be pretty similar because it has the same parent, and therefore it's initialized in the same way, and it also has a roar function. But then we might have a cow subclass representing something closer to the diagram that I showed you in the animation. It's going to initialize the name in exactly the same way, but we're going to have a moo function. So I'm just going to say that whatever moves. So let's create some instances just to make sure that we can call all the functions that we think. So first of all, let's create a cow named Katie. My wife and I went to Scotland pretty recently, and we met a Highland cow named Katie. So I always think of Katie when I think of cows. Let's create a lion named Nala. This is just from the Lion King, so not very creative there. And then Shere Khan from the Jungle Book is going to be our tiger. All right. So let's first of all make all the animals eat. That's not going to be super interesting in terms of the output. It's just going to say Katie eats, Nala eats, Shere Khan eats. But I will just say that this is a lot more interesting behind the scenes because none of these classes, cow, lion, or tiger, define the eat function. We actually have to go up the chain in order to find the function, but it, of course, does get called. So Katie can moo, Nala can roar, and Shere Khan also can roar. Okay, so here I'm trying to point out that tigers and lions, a tiger is not a lion, and a lion is not a tiger. So it's not appropriate for them to have an is-a relationship or an inheritance relationship. But they both happen to have a roar function. There is a way that I can squeeze that into inheritance. For example, I could make a class between animal and lion. So for example, I could say big cat, and big cat would be a subclass of animal, and lion and tiger would both be a subclass of big cat. And then I could define the roar function on big cat, which would mean that both lion and tiger would inherit it, and I wouldn't need to write the function more than once. So that's something to keep in mind. From a design point of view, that's an option, but for just our simple purposes today, this is okay. So notice that there isn't anything special about the fact that I have the same function here. It's not a contradiction. Python's going to allow me to do it, but it's something to keep in mind that those classes are not related directly to each other. They're both animals, and so I can use a tiger or a lion where I use animals, but I can also use a cow, even though a cow looks quite different. And just keep in mind, if I have a function that expects to receive an animal, it's possible that function will make the animal eat, because the eat function is available in the animal class. But it's very unlikely, in fact, very bad practice, to have it make the animal roar, because not all animals even have a roar function. So one of the three subclasses that I have of animal doesn't have a roar function at all. So if I were to write a function that took an animal as an argument, and then I called the roar function on that animal, that would be inappropriate. I wouldn't be using those classes properly. I should only call functions that are available on the type of object that I expect to receive. So if I specifically ask for a tiger, then I can call roar on it, and I can also call eat, because that's available on the tiger class. All right, anyway, let's run this program now. And looks like I messed things up. That's fine. So it's just saying on line 108, so it expects 2 arguments. Oh yes, I did make a mistake there. So here I'm calling super.init, and I did this on all of the subclasses. And so it provides the self for me, so I don't need to provide the self here. So all 3 of these are unnecessary. It's sort of like I'm passing self twice, because super will give me the same object, the current object, but in its animal form, I guess. It'll give me it knows that it's an animal, and also name is being passed. So the 2 arguments are both being passed here. It's saying 3 were given because I kind of passed self twice. All right, there we go. So you can see anyway that the animals all eat and roar and move. All right. All right, so that's enough for today. I'll see you next time.